The Waterjet is widely recognized as one of the most effective cutting methods available, but most people don't realize just how or why it's so useful. Today, Waterjet cutting enjoys almost universal acceptance by a vast array of industries and applications. Using a CNC-controlled stream of focused, ultra-high-pressure water, combined with a fine abrasive, industrial waterjets cleanly and precisely cut nearly any material in thicknesses up to 12 inches or more. Let's see how waterjets accomplish this amazing function. In its simplest form, a waterjet cutter consists of a few main components. The heart of any waterjet is the cutting head. The cutting head consists of the high-pressure water feed, the abrasive feed line, the jewel orifice, the mixing chamber, and finally the mixing tube. The orifice is typically ruby, sapphire, or diamond, with a very tiny hole to focus the water beam. After the high-pressure water travels through the orifice, it is mixed with abrasive and then shot through the nozzle onto the workpiece. The abrasive does the actual cutting, while the water is simply the mechanism to accelerate the abrasive particles. Essentially a water-filled tank, the cutting table supports the workpiece, absorbs and dissipates the power of the cutting stream, and collects the used abrasive. The brains of a waterjet is the CNC computer. It uses a G-code file made from your CAD drawing and sends commands that physically move the cutting head along the outline of your design. The commands from the CNC computer are received by the XY travel system or gantry, which is a vital part of the waterjet cutter. The abrasive storage hopper is a pressurized tank that holds the fine abrasive and forces a steady flow into the cutting head to mix with the high-velocity water stream. Lastly, there is the high-pressure pump, the lifeblood of the waterjet. The pump pressurizes the water stream to between 60 and 90,000 psi. As this high-pressure stream passes through the jewel orifice, that pressure is converted into velocity, and the resulting stream then exits at around 2,500 miles per hour onto the workpiece. You've seen how a CNC computer, a gantry, cutting head, cutting table, high-pressure pump, and abrasive hopper combine to create a powerful cutting force. Now let's learn what an industrial waterjet can do. Waterjets cut using a micro-erosion process, and since all materials erode, waterjets can cut nearly anything. With its unique cutting method, the waterjet cuts an extensive range of materials, including metals such as different grades of aluminum, carbon steel, stainless steel, and titanium. It also cuts non-metallic materials such as carbon fiber, borosilicate, soda lime, and art glass, most types of stone, ceramic, porcelain, and tile, plastics such as HDPE, acrylic, and polycarbonate. It even cuts soft materials like silicone, neoprene, polyurethane rubbers, and high-density foams. The list of materials that can be cut on a waterjet is almost endless. Who uses a waterjet? Engineers rely on waterjets to iterate faster and work in end-use materials. Manufacturers rely on their ability to quickly cut any material without the need to buy additional tooling. Educators use the waterjet to give their students hands-on experience working with varied materials using modern industrial technology. And artisans enjoy the ability to cut intricate designs in unique materials that are otherwise difficult or impossible to create by hand. There are many ways to cut sheet materials using CNC precision, with the four most common being lasers, plasma, machining, and waterjet. Laser cutting offers great accuracy, with good edge quality, and there is minimal taper on the cut edge. But due to the high heat involved, there is a heat-affected zone that may distort your cut piece depending on the material and end use. They are also limited to non-reflective materials, produce dangerous fumes, and can cost upwards of $200,000. Plasma offers affordable and fast cutting of conductive metals, but it cannot cut other materials and sacrifices edge quality and precision. It also produces a significant heat-affected zone and can distort thinner materials. They also produce toxic fumes. Machining technology produces exceptional dimensional accuracy with quality edges in plastics and metals, but at the sacrifice of time. It is not the most effective method for 2D cutting or for cutting thin materials. Machining also requires a significant investment in consumable tooling. Large format Waterjet cutters overcome many limitations of other cutting technologies and offer the unique ability to cut nearly any material with great accuracy and edge quality without a heat-affected zone. While eliminating dangerous fumes and hazardous waste, they require a significant amount of space, power, and water infrastructure and maintenance. They'd also cost well over $100,000. Enter the WAZER. The newest technology, the WAZER offers many of the advantages of large format water jets, but in a much smaller and more affordable package. It produces highly accurate cuts with good edge quality in nearly any material without a heat-affected zone, and it accomplishes all this with minimal infrastructure needs. How is the WAZER different? The WAZER was designed to operate at a much lower pressure than its large format cousins. This lower pressure gives the water pump a rated lifespan of 800 hours before rebuilding, and the nozzle is rated for 300 hours of cutting time. However, there is a trade-off, as the WAZER cuts much slower than the large format machines and is generally limited to materials 1/2 inch thick and under. It requires only standard single-phase power, tap water, and a drain to operate, and reduces the tedious maintenance task of cleaning through its unique used abrasive collection system. What can you do with a WAZER? With the small format WAZER Waterjet, there are many applications that can now take advantage of waterjet cutting. These include rapid prototyping, R&D, tooling creation, customized end-use parts, low-volume production, and more. In addition to industrial companies, even small businesses, schools, and professional artists with limited space or budget can afford a waterjet. You've seen how a handful of components come together to form an industrial machine so powerful it can cut through almost any material. What would you cut with a waterjet?